Welcome back. This is chemistry question 51 from IMAT 2018 past paper. So I'll be answering this and solving. So when nitrogen and hydrogen are mixed under suitable condition of temperature and pressure and in presence of catalyst, an equilibrium state is attained. So we have nitrogen gas reacting with hydrogen gas to give ammonia gas. So we know this is also Haber process for producing ammonia as a yield. And we have here the thing that explicitly states the enthalpy change is negative. So what this means is the forward reaction is exothermic. So the forward reaction is exothermic, meaning that the right side, the yield, the ammonia yield is favored by exothermic direction, which is why it's negative. So now we have here which of the following statements explains why when the pressure on mixture of nitrogen and hydrogen is increased while the temperature remains constant and time taken to attain equilibrium is decreased. So the condition that they set condition. So we already know that there is a catalyst and everything, and the pressure is changed and it is increasing. It changes by increasing the pressure, and the temperature is kept constant, so it's fixed, doesn't change. And so the main part of this question is that they're asking about time taken to attain equilibrium. So like how much time it takes. So the less amount of time is taken to reach the equilibrium. So now we're gonna go through each statement so we can solve this question. The first statement mentions the molecules have higher collision frequency. So yes, this is true. So why it's true? Because we know increasing pressure reduces the time taken for equilibrium to reach, because the what happens is as you increase as pressure increases, the the gas molecules are drawn closer to each other. So they're drawn closer to each other, and so therefore they increase the number of successful collision per unit time as the collision happens more often. So that's why increase in pressure will increase the collision frequency. So like for example, these are gas molecules they're randomly colliding. So when you reduce the amount, when you like increase the pressure, so this forces the molecules to come close to each other, and thereby they increase more collision. They each other more often, so more collision happens. So that's how the increase in pressure causes this effect. So now moving on to the next statement. Statement 2 says the yield of ammonia NH3 gas decreases. So we can easily rule this out because we know the question is mainly focusing about time taken to attain equilibrium rather than asking about the yield of ammonia. But still, generally, even if they ask both, like time taken, also the yield of ammonia, we must know that increasing increase in pressure generally favors fewer moles of the reactants or the product. So increase in pressure will favor fewer moles in the reaction. So we know which has the highest mole in this reaction. So the reactant side, we have 4 moles, and on the product side, we have only 2 moles. So increase in pressure will obviously increase in the yield of ammonia because it favors few moles, and the fewest mole is the ammonia gas that are being produced, only 2 moles. The reactant side has 4 moles, so that's much higher moles. So statement 2 is wrong. In general, increase in pressure will favor few moles, which is the ammonia gas in this context. But still, we would ignore this because we're focusing on the time taken for equilibrium to reach. And the third statement mentions the greater portion of molecules in the mixture have greater have energy greater than the activation energy. So we will try uh, drawing a sketch diagram so that we can understand the statement. So basically, we can rule this out as well because we know generally the portion of molecule. So this portion of molecule, we must know this relates to Maxwell-Boltzmann energy distribution. So it's related to this distribution. So we know that the energy distribution graph, the kinetic energy of molecules is mainly dependent on the temperature. It's mainly dependent on the temperature, the kinetic energy of each molecules. So for having the molecules kinetic energy above the activation energy, the only way we can do this is by increasing the temperature. So it's mainly dependent on temperature, not the pressure, because what we know about the pressure is that pressure mainly affects how often molecules collide. And about temperature, it mainly affects the kinetic energy of molecules. So increase in temperature increases the thermal energy. So this thermal energy is then taken in and converted as kinetic energy for the molecules. So that's why temperature affects the kinetic energy for mixture of gas to have energy greater than the activation energy so that they can proceed to a reaction. But we know here it also states that temperature remains constant. So that's why the statement is wrong. So generally we can draw a graph so that we can understand more about the how temperature affects this. So we know about the Maxwell-Boltzmann distribution graph. So I'm gonna draw a graph of Maxwell distribution, the energy distribution graph. So we have this x-axis over here and the y-axis over here. So in the y-axis we have the number of molecules. So number of molecules, and down here we have the kinetic energy. So we have this slightly bell-shaped curved, not exactly, but at least it resembles it. So we generally have this activation energy over here. So this is the energy barrier. So in this shaded part of diagram, this represents, I'm going to use different color. So this part of shaded curve, the shaded diagram in this curve region states that these are the only molecules with required energy, required activation energy to be able to proceed to reaction. And on this part the graph of the curve, which is the white part, this is the most molecules that don't have the required activation energy to proceed to the reaction. So this is how the Maxwell-Boltzmann energy distribution graph looks like. So we know, as we discussed, the only thing that affects this distribution is the temperature. So if we draw this, if we increase the temperature, what happens is this shape shifts more to the right side of the graph, and so the amount of, while still the activation energy remains the same. So what's the effect on having increase in temperature is that as we increase the temperature, this will shift more to the right side so that more number of molecules will have the activation energy to overcome the energy barrier from the activation. So actual statement is the increase in temperature will cause the more of the molecules to have more kinetic energy to overcome the required activation energy so that they can proceed to the reaction. So this is how the distribution works, an increase in temperature. And we also have the catalyst that can also affect the number of molecules having the energy, but it won't affect the distribution graph. So this is how it is exactly if we add the catalyst. But we know in the question they've also stated that there is catalyst added in the presence of catalyst. So when we add the catalyst, the distribution graph remains the same, but the activation energy with the catalyst reduces the amount of kinetic energy required for the molecule to proceed to the reaction. So the energy barrier is reduced. So that's how catalyst speeds up the reaction without altering the distribution curve. So that's all about the Maxwell-Boltzmann distribution graph. So that's why pressure, so that's why the pressure increases the frequency of collision, but does not, but it does not affect the kinetic energy of, sorry, so it does not affect the kinetic energy of individual molecules in the reaction mixture. So the pressure has nothing to do with the energy distribution graph. So pressure only affects the frequency collision. So that's why option 3 is wrong. So now the only option that's correct is option E, which is statement 1. So that's why this statement is wrong and only a correct option is option E. So that's how we solve this question. So I hope you find this video helpful. So thank you guys for watching my video. Please leave a like and subscribe to my channel. Thank you guys. Bye.